Okay, so now we are going to have, now we have our hexadecimal. Now we have another example for decimal, which is 3,000 in decimal format. So now we are going to find a binary, octal, and hexadecimal. Okay. So first, as in the first video, or in the before this one, so always translate everything into binary so that when you get the octal and hexadecimal, it will be easier for you. So now we have a binary first. Okay, binary first. So when we translate everything into binary, always in long division from decimal. So 3,000 divided by 2. So now we were going to have our 3,000 divided by 2 because binary is always two numbers, 0 and 1. Okay, 0 and 1. So now let's have it. 3,000 divided by 2 is 1,500. So is there a remainder or not? So no, there's no remainder. So let's put a 0. Okay, another one. Until it reaches 1. So 2. 1,500 divided by 2. So 750. So is there a remainder? No. So 0. Another one divided by 2. So 375. So there's no remainder. So 0. Another one. 375 divided by 2. So 187. So is there a remainder or not? Let's check. So 187 times 2. So we have 4, carry 1. So 7, and then 2. Okay? 374. 374. 3, because it's carry 1 as well. So 374. So 375 minus 374. Okay. So 1. So we have a remainder of 1. Okay. So always remember, if you want to make sure that there's a remainder, you need to you need to times the answer, the quotient, the 2, just like how we did it. Then minus the product to the 375, this one. So to make sure that you have a remainder, okay? Have a remainder. Let's go. So now we have another answer. So divided by 2. So 187 divided by 2 is 93. So let's have it. 93 times 2, 6, and then 186. So 187 minus 186, 6. 186 is 1. Okay, 1. Now, another one we were going to put here. Okay, so 93 divided by 2. Okay, 93 divided by 2 is 46. Is there a remainder? Let's check. 46 times 2. So 12 carry 1, 92. 93 minus 92, 1. So there's a remainder, 1. Okay? Next, 46 divided by 2 is 23. Is there a remainder? No. So 0. Always remember that when it is not divisible by 2, there's always a remainder. Okay? So just like this. So 23 divided by 2, so 11. So let's check. Okay? 11 times 2, 2, 22. 23 minus 22, 1. So it's always 1. It is not divisible by 2. So 11. Let's now have it 11. 11 divided by 2. So 5. There's a remainder, 1. Then 5, 2, 2, 1. Okay? So now we're going to have it all up. All up. Okay, so let's have it. Okay. So we have 2. So 2 divided by 2, 1. So 0. So now we're going to make it up. Up, 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 and away. Always use it by 1. Up, up, then up. Okay, so now we have 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 0, 0. Okay, that's a mouthful 1. Mouthful binary. Okay, that is the binary of 3000, which is 1, 1, okay, 1, 1, 1, 1, 3, 1. Then there's a 0 to make sure it's always on up. Okay, so 1, 0, 1, 1 is 1. Then 1, 0, 1, 1, 1, 0. Okay, so that's it for the binary. Now, how about the octal? So remember in octal, we will go to group them into 3. 3 groups. So let's put our binary. So 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 0, 0. Okay, let's group them into 3 members. So there's this, which is, and then this one, and then this one, and then this one. Okay, now we have 1, 2, 4, 1, 2, 4, 1, 2, 4, 1, 2, 4. And then cross out zeros. Okay, firstly, the first group, this group. So 4 plus 1, 5. 4 plus 2. This is the second group. 6. 4 plus 2 plus 1 equals 7. And then there's none for the other group. So our answer for our octal is 567. 567 to the octal. Now, let's rewrite again the binary to find our hexadecimal. So, 1 0 1 1 1 0 1 1 1 0 0 0. Okay, let's group them into 4 members. 1, 2, and then 3. Okay. So we have 3 groups. Firstly, let's have the 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. Okay, now let's cross out all the 0. All the 0. Now, let's have our first group. So 8 plus 2 plus 1. So 11. So now our second group, same 11 and then 8. So now we have our 11 here for our first and second group. So how can we answer this? Okay, so we have our letters, right? Letters from 10 to 15. So A is 10, B is 11, C is 12, D is 13, 14 is E, and then F is 15. Okay, so now we have our 211 here. So our answer for our hexadecimal is 2B. So B 8 to the 60. Why B? B is 11. We have 211 here. So now it shorts for 11, 11, 8. But in hexadecimal, 10 to 15 is always the letter format. Okay? And we base it here on we group them into 4 members. So we have our whole number is 8. So 11 is not part of the 0 to 9 from the 16. So 10 to 15 is always A to F. So that is our answer for today, which is B 8 to the 16. So that's it for our decimal to binary, decimal to octal, decimal to hexadecimal. Always remember that when it is always, the given is always the octal, hexadecimal, binary, decimal, you must always find the binary first so that when all of it will be easier for octal and hexa when the given is a decimal format. When the octal is the given, must find first the binary. And then it will be the same. Like it is always the same from our previous parts. Okay? It will always be the same. It will run and over again. So it will always be the same, even it is different given, whether it's octal, hexa, and then you translate it to decimal, binary, or any other, well, vice versa. It will always be the same. So that's it for our lesson for numbers, numbering system. Okay. So today we were going to have another example for an octal. For this, we have 177 to the octal power. So we were going to find the decimal, the binary, and the hexadecimal. So as per previous, we will always find the binary. Why? Because it is easier to find the decimal and hexadecimal when we have our binary. So firstly, we're going to find the binary number of 177, the octal power. So we are going to have 177. So as in the previous, in octal, we have 1 to 4. 1, 2, 4. So that is the Y4 because it is the divisible of 8. I mean the when 4 times 2 or 2 cubed is always 8, right? So it is the always the ending of the number, which is 4. So right now we were going to find the binary. So we were going to group as usual. We were going to group them into 3 groups. Okay. 7, 7, and then 1. So in each one, we're going to have 1, 2, 4, 1, 2, 4, 1, 2, 4. I mean, let's put it this way. So 7, we have 4, 2, 1. Okay. So we were going to add them. Wait, let me change the color. We were going to add them, okay, to see if what is the binary of 7. Because there is a binary in each number. So like 1. So the binary of 1 is 0, 0, 1. And then for 2, we have 0, 1, 0. And then for 3, we have 0, 1, 1, and so on and so forth. Because we have the given 4 to 1 or 1 to 4, depending on what understanding you want to have our solution. But for this one, to make it not confusing, we're going to have 4 to 1. So in each number, remember this, in each number, there is the specific binary for it. So for this one, what is the binary of 7? So we're going to find out. So 4 plus 2, 6, right? But it's not enough. So we have 6 plus 1 is 7, right? So now, how do we translate this? So it is 1, 1, 1. Why? Because 4 plus 2 plus 1 gets. So 4 plus 2 is 6. 6 plus 1 is 7. Okay. 4 plus 2 plus 1. Same as the second group. 1, 1, 1. Now, as I said, the 1, there is a specific binary for each number. So there's 0, 0, 1, 2, 0, 1, 0, 3 is 0, 1, 1, 4 is 1, 0, 0, then 5, 1, 0, 1, then 6, 1, 1, 0, then 7, 1, 1, 1. Okay. So now we will going to find the 1. So we have here the 1, 1, 0, 1, 1, 0, 0, 1, 0, 1. Now, we will going to have it. So how do we going to answer the binary here? Because we have the 0, 0, 1 for the 177. So we will going to cancel them because that's the invisible 0. But we will going to use them. Okay? We will going to use them. So our binary is 1, 1, 1, 1, 1, 1, 1. That's our binary for today. Okay. Next, decimal. Okay. So our decimal will be, let's change color to violet. Okay. We're going to have our decimal. So remember, in our decimal, we have the 1, 2, 4, 8, 16, 32, 64, so on, so forth. Okay, until we reach the 0. So we have 1, 2, 4, 8, 16, 32, 64. So we will going to cancel them because that's the 0. Our invisible 0. So we're going to add them all because that's 1. All 1. So 2 plus 1, 3. 4 plus 3, 7. 8 plus 7, 8. So 15. 16 plus 15, 31. So 31 plus 32, 63. Then 64 plus 63 is 127. Okay. So we have 127, 10. That's our decimal for this time. Let's erase this. Let's rewrite the number again. Let's rewrite. That's what the red. 0, 1, 1. 0, 0, 1. 0, 1, 1, 1, 1, 1, 1, 1. Okay. Now we have our decimal. Let's see if we were going to find a hexadecimal. So right now, we were going to group them into 4. Let's make it a orange. So we have this, and then we have this. Okay. So we have 4 groups, 2 groups. So let's change, let's put the 1. So 0, then 0, 1, 1, 1, and then 1, 1, 1, 1. So 1, 2, 4, 8. So let's put a kind of group. So let's have 1, 2, 4, 8. 1, 2, 4, 8. 1. Okay. So we will get to cancel the 0. So we have the second group. So 4 plus 2 plus 1 is 7. So we have the whole number, 7. How about this one? 8 plus 4 plus 2 plus 1. So let's have 2 plus 1, 3. 4 plus 3, 7. 8 plus 7, 15. So we have 7, 15. But it's not the answer because remember 10 to 15 is always A, B, C, D, E, F. Okay? So 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and then 15 is F. So which is? So our correct answer is 7F. 7F. 7F to the 16 power. So that's our answer for hexadecimal because remember 10 to 15 is A to F. So the 15 is not always going to be the whole number in hexadecimal. It's always the letters. Okay. And then why 7? Because that's the whole number that reaches up to 10. But the 10 is the boundary for our decimal. So that's it. It is just like before from hexadecimal. Then if the given is hexadecimal, if the given is decimal, if the given is binary, if the given is decimal octal, always remember that see the binary because it is easier when you put the when you find the decimal, octal, and hexadecimal. And in hexadecimal, it's always the 10 to 15. And in octal, there is a uh, corresponding number. There is a there's a binary for each number. So yeah, that's it for our number system.